Hello everyone and welcome to this new video about the Go programming language. Today we're going to look at pointers. So the idea of a pointer is something that usually the beginners in the programming language struggle a lot with at the beginning. So I will have to introduce the key idea before we actually move on to the code. And so if you come from C and C++, you have a great advantage because you're already familiar with the concept of pointer. But if not, then I will have to just start from scratch and explain what a pointer is. So if you come from, again, one of the languages that use pointers and in general, like direct memory referencing, then you can just skip all of this and don't worry about it. If not, I'll just stick with this little explanation that I'm going to give. So when we write a program, and for example, we declare a variable, x int is equal to 5, or for example, y is equal to true, okay, something like that. Well, the value of this variable gets stored in memory, in particular in what is called primary memory. That is basically RAM. That is a memory that we can access pretty fast. I mean, it's lower than registers, but still relatively fast. And then at this value that we declared and initialized, it gets assigned a memory value. So you can imagine memory as all these blocks of cells of memory with some values inside. Okay, you can imagine actually as a table. So you have like here the address. So for example, I don't know, address number 10, and then here the value, in this case 5. So the way in which actually memory works, you will understand that when you work with very, very low level programming languages, such as for example assembly or stuff like that. But just see this as a very high level, simple model of how memory works, okay? So imagine that you have this value here, 5. Then I don't know, in value 11 you have some other value that you declare throughout the program and so on. Okay, but now, so what you can see is that in memory, when we declare and initialize variables, we have a memory address and then the value stored inside the memory address. So you can think of memory address that is pointing to some value and then the value. In the same way here, 11 pointing to this value here that we have not declared yet. And also we're not ready to understand how arrays actually work in memory. So there's just contiguous storing of values in memory. So for example, imagine that we're storing an array of, for example, 5 integers. It's the following 1, 2, 3, 4, 5. Well, then how will it be stored in memory? We'll store, for example, at address 20, it will store, I don't know, 1. Then address 21 will store 2. Then so on, and then up to address 25, it will store 5. Address 24 will store 5. So as you can see, this is the basics of how memory works, you know, but in a very high level view. But this is all you need to understand what a pointer is. We don't need to actually see because, you know, we're not being super precise because, of course, and so we do not really need to worry about the super low level stuff for now. And well, what a pointer really is in programming is just an address of memory. So when you work with a pointer, you're working with an address of memory that points to some value. And that's all a pointer is. And in Golang, just like in C and C++, when you have a pointer, you also want to specify the type of pointer that you have. So a pointer can either be, for example, a pointer that can point to some integer. In this case, this is a pointer that points to an integer. So this address of memory points to an integer value. And so we will define a pointer variable. We will say that this, for example, is a pointer variable of type a pointer that points to an integer. So to denote a pointer that points to an integer, we will use this star operator and then the type integer. But again, if we had a pointer that pointed to a boolean value, we will just have star bool. But for example, let's just keep int here. Okay, so this is really all you have to know, and that is what pointers are basically. So now we just need to learn how to work with pointers inside the program. So imagine that you have again this pointer variable here, and actually up here, let's keep this variable here. So you have that variable here up there, x. Okay, now let's try to print out x. As you can see, we get actually we need to use also the pointer variable. So I'm gonna do something. When we work with pointers, there are two operators which are very, very important. The first one is this commercial e sign, and the second one is this star operator. So the first one is this commercial e sign, which is called the reference operator. So this acts on values. What it does is it returns the address of memory in which the value is stored. Then the second operator is called the dereference operator. And what it does is precisely dereference a pointer. What it means is that it takes the reference, which is the memory address, and it returns the actual value. So it takes the actual value with respect that the pointer is pointing to. So now let's apply it. And now one thing that you should not be confused about is that this star sign is precisely the same star sign that we used up here. But now you will say, well, did we use an operator in this declaration here? Well, the answer is no. When we declare pointers and we use, for example, this star here, or for example 2 stars, we will see what that is. That is actually that's pretty easy to understand, because it's just, you know, we could say inductive, you know, because that is just a pointer to an integer. And so that is not really hard to understand. But what we used up here is not an operator. It's just a way to tell the compiler where we're declaring a pointer variable. This is a type. This is a variable of type pointer to integer. So that's it. On the other hand, the reference operator is when we already have a pointer type, when we want to reference it, so to access the value that is stored in that address of memory. So let's try to work with this. So up there we have a variable x, a plain integer variable of equal to 5. So let's declare another variable y, and let's, for example, set equal to the address of memory of x. So we have learned how we can access the address of memory of a variable, that is using the commercial e sign. Y is a pointer variable. If we wanted to not use type inference and just declare it the long way, we'll have to write we have declared it up there, so we can just say pointer variable is equal to the reference operator applied to x. Now what we can do is we can so inside the pointer variable we have the address of memory in which 5 is stored, so the variable x is stored. Now in order to, so this is basically an address of memory. So if we try to print this out, let's see what we get. Print the line pointer, wait, did I mess, oh yeah, I messed up the syntax. So this is pointer variable. Let's try to print it out. As you can see, we get this hexadecimal number, which is basically the location in memory in which the x variable is stored. But what if we want the actual value? Well, in order to get the actual value, we will have to dereference it, as we've seen above, using this star operator. So if we try again, let's see what we get. We get 5, which is the actual value. Now, we have mentioned above that we can have not only pointers to some data type, we can actually also have pointers to pointers. So imagine now that we want to declare pointer to pointer. That is a pointer to an integer. And then we can set pointer to pointer equal to the reference operator acting on pointer variable. So let's try and print out, for example, the value of pointer variable. Then we can print out pointer variable, pointer to pointer, and then we're going to dereference and print pointer to pointer. Let's see what we get. Pointer to go. Okay, so as you can see, we will get in the first case the memory, the value that is stored inside this memory address here in hexadecimal, and then which is basically the address of 5 of x. Okay, because as you can see here, our variable, pointer variable, is the reference operator acting on x. So it's basically its address in memory. Then we have pointer to pointer, which is the address in memory of the pointer variable that points to 5, that points to x actually. So, and this is the address here. Okay, and as you can see, it's different than this one. But then if we dereference it, dereference this variable that is a pointer to a pointer variable, so it stores an address of memory. We will see what value it points to. So we dereferenced it at the end. Well, we can see that it points to a memory address, and this memory address is precisely the memory address of the pointer variable that points to x. So I know it might sound a little confusing in the beginning, but I'm sure like that just by working with them, you'll learn how to deal with them, how to work with them. In the next video, we will see how we can use pointers. So now you should have a decent understanding of what a pointer is, what pointers do, what dereference operators are, and so on. But now in the next video, we'll see how we can actually use them in a Golang program, practically. So what are they used for? So why are they useful at all? You know, in the next video we will see that, and you will see that pointers are really, really powerful, and they're a really great tool to use in your programs.